Namaste. I am Mrs. Arumugalakshmi. Good day, everyone. Today we are going to discuss the problems in Lesson 4 Work, Power and Energy of Class 11 Physics. The first problem. Two objects of masses 2 kg and 4 kg are moving with the same momentum of 20 kg meter per second. First, will they have same kinetic energy? Next, will they have same speed? These two we have to find. So first we will find the kinetic energy. The relation between kinetic energy and momentum. We know this relation as kinetic energy is equal to p squared by 2m. So for the object of mass 2 kg, the kinetic energy is represented as Ke1, whose momentum is given as 20 kilogram meter per second. So 20 square, substituting in this formula, we have 20 square divided by 2 into mass of the first object is 2. So 20 square divided by 4, which is 400 by 4, which is equal to 100 joule. This is the kinetic energy. Now for the second object, we have to find the kinetic energy. So that is represented by again by the same formula p squared by 2m. P value will be the same. So 20 square, which is 400 divided by 2 into m. Here the mass value is 4 kg. So 2 into 4 it is 80. So 400 divided by 8 it is 50 joule. So they will not have same kinetic energy. Their kinetic energies are different. Next, will they have same speed? The momentum is constant, but they have given that P is equal to mv. The momentum depends upon both mass and velocity. So, if they have, the masses are different. Hence, if the momentum is same also, if the masses are different, the velocity will also be different. So the velocity, that is the speed, will not be the same for the two objects. Next problem. An object of mass 2 kg is taken to a height 5 meter from the ground. Here they are asking us to assume the g value as 10 meter per second square. Now we have to calculate the potential energy stored in the object. Next, where does this potential energy come from? Then what external force must act to bring the mass to that height? Then what is the net force that acts on the object when the object is taken to a height? So first let us calculate the potential energy. We know the formula for potential energy as mgh, mass into g value into height to which it is lifted. So mass value here it is given as 2 kg. G value they are asked us to substitute the value as 10. And the height is 5 meters. So 2 into 10 into 5. That is m into g into h, which is equal to 100 joule. This is the potential energy. So from where this potential energy comes from? The potential energy comes from the external force with which you lift the object. From that only the potential energy comes. So we have answered first and second. Next, what is the external force which must act to bring the mass to that height? So the external force is nothing but the opposite to the gravitational force. Gravitational force will be pulling any object in the downward direction. Now we have to apply external force against this gravitational force to lift it to a height 5 meter. So the applied force is nothing but the gravitational force, but it will be acting in the opposite side. So it will be Fa is equal to minus Fg. Fg we know the formula, gravitational force, it is m into g. Since it is acting in the negative y-axis, we have minus sign. Since it is acting in y-axis, you have got the j cap unit vector. So Fa value is equal to mg j cap. Next, we have to find the net force acting on the object. The net force, actually two forces will be acting. One force is the gravitational force which is acting downwards. The other force which is opposite to the gravitational force which is acting upwards. Hence, the two forces will balance each other. The value of the two forces are equal in magnitude and opposite in sign. So, the two forces will cancel each other and the net force acting on the object is equal to 0. Next problem. A body of mass m is attached to a spring which is elongated to 25 cm by an applied force from its equilibrium position. Calculate the potential energy stored in the spring mass system. What is the work done by the spring force in this elongation? Suppose the spring is compressed to 25 cm. Calculate the potential energy stored and also the work done by the spring force during the compression. Here the spring constant value K is given as 0.1 Newton per meter. So first let us find the potential energy stored in the spring mass system. So displacement is given as x is equal to 25 centimeter. Whatever values are given, we have to convert it into SI unit. So here it is converted into meter as 0.25 meter. So the potential energy is given by the formula U is equal to half kx square, where k is the spring constant, x is the displacement. Substituting the k value and x value from the question, we have half into 0.1 into x is 0.25 the whole square. So when you multiply and divide, you get the answer as 0.0031 joule. This is the potential energy. Next, we have to find the work done. So work done, we know the formula as work done is equal to F dot dr. Here the object is given a displacement x. So the work done is, the total work done is integral 0 to x. 0 is the initial position, x is the final position. So 0 to x, F into dr. The value of F you know from the Hooke's law, F is equal to minus kx, where k is the constant and x is the displacement. Since this force is acting in the x-axis, we have the unit vector I cap, which is for the x-axis, dot dr. Dr means it is the displacement. Here the displacement is dx, and since it is in x-axis, we have the unit vector as I cap. Here we have got the negative sign, which says that the direction of force and the displacement are opposite to each other. Hence we have the negative sign. Now to find the force, we have to integrate this equation. So while integration, we will take the constant k outside. Minus sign also you can take outside. So minus k into integral 0 to x dx. Integration of x is x squared by 2. So for x, when you apply the limit 0, you will get the answer as 0. When you apply x, you will have the same answer. So the value of work done is minus half kx squared. Now you can substitute the k value as 0.1, x value is 0.25. So when you substitute these values in the equation and simplify, we get the work done as minus 0.003 joules. Next, what we have to do is, the spring is compressed to the same 25 centimeter. Now, for this compression, you have to find out what is the potential energy and the work done during the compression. So, during the compression also, the potential energy, since it is compressed to the same distance, the distance is not different. First, initially it was elongated to 25 centimeter. Now it is compressed to 25 centimeter. Hence, the potential energy will be the same. The value will not change. So, U is equal to minus kx squared. You will be getting the same value of potential energy, which is 0.0031 joule. Similarly, we have to find the work done. So, work done by the restoring spring force. When you compress and when you leave it, what happens? The spring will come back to its original position by the action of the restoring force. So work done is calculated by using that restoring force, which is equal to, work done is equal to integral 0 to x f dot dr. Here f is given by, again according to the Hooke's law, f is equal to minus kx. Since it is acting on x-axis, we have got the unit vector along x-axis as I cap. Similarly, the displacement is along x-axis, so the displacement dr is replaced by dx, and it is again along the x-axis, so we have the I cap. Since the restoring force and the displacement is along against the x-axis, we will be having a negative sign here. So once again, you have to take the constant outside, and when you integrate x, you have x squared by 2. So again, substituting the k value, x value, you will be getting the same answer, 0.003 joule. The fourth problem. Compute the work done by the gravitational force for the following cases. So first, the object is moved from A to B in path 1. So in this case, we have to find the gravitational force. Next case, first let us do this and then move on to the next one. So we know that force is given by the formula m into g, because this is the gravitational force. Since it is acting in the negative y-axis, you will have the unit vector as minus j cap. So the force is equal to minus mg j cap. Here the displacement is given, is plotted in x and y-axis. So the displacement will be having, the displacement vector will be dr vector is equal to dx I cap plus dy j cap. But here, if you see the diagram, the object is moving only in the y-axis. So the x-axis will be, the x-axis component will be 0. Hence, the work done is given by integral a to b. The object is moving from a to b, f dot dr. So here, instead of dr, we will be applying dy, because the object is moving only along the y-axis. X-axis, there is no movement, so we neglect that. So f, you have to substitute the f value as minus mg j cap, and the displacement is minus dy j cap. So when you multiply this, j cap dot j cap, we know the value as I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1. So that value will be 1. The remaining you will be having mg into dy. So mg is a constant, so that you can take it outside. So you will have mg into integral dy. The limit will be 0 to h, because h is the height through which the object is lifted. So integration dy is y. When you apply the limit h, it becomes h, minus when you apply the limit 0, the whole term becomes 0. So work done in the path 1 is minus mgh. Next, if you see the second path, instead of moving from A to B directly, the object is moved from A to C, then C to D, then D to B. So the total work done in the path 2 is given by integral A to B f dot dr is equal to integral A to C f dot dr plus integral C to D f dot dr plus integral d to b f dot dr. So you have to find the three values separately, then we have to add them to get the total work done. So first let us find the work done from A to C. From A to C, if you see, the work done is given by the formula, usual formula only, f dot dr. So f, the gravitational force will act on the y-axis, so it will be j cap, so minus mg j cap. Here the displacement A to C is on x-axis, so the displacement will be dx I cap. Now we know the value j cap dot I cap is equal to 0. The value of I cap dot I cap is only 1, but the value of j cap dot I cap is equal to 0. Hence the total work done from A to C is equal to 0. Next, Next we will find from C to D. C to D already we have found in the path 1, the same only. So integral C to D minus mg j cap dot minus dy j cap. So it will be mg integral dy, so it will be mgh. Now the third one. The third one is again, if you see, it is from D to B. So the displacement is along x-axis, the force is along y-axis. So it will be j cap dot I cap, so it will be again 0. So the total work done is minus mgh. Fifth problem. Consider an object of mass 2 kg moved by an external force 20 Newton in a surface having a coefficient 0.9 to a distance of 10 meter. What is the work done by the external force and the kinetic friction? Mass is given as 2 kg, the distance is given as 10 meter, the external force is acting which is given as 20 Newton, and the kinetic friction, the coefficient of kinetic friction is 0.9. So when the object is in movement, it experiences two forces. One is the external force and the other one is the frictional force. Frictional force is given by Fk is equal to mu k into N. N we know, the magnitude of N will be equal to mg. So the frictional force value is Fk is equal to mu k into mg. Substituting m value and g value, we get kinetic friction as 18 Newton. The external applied force is 20 Newton. So now you can easily find the work done by the external force. Work done formula is F into D. So external work done, if you have to find, we have to find the external force value, which is 20 Newton. So 20 into 10 will be 200 Joule. Now when we have to find the work done by the kinetic friction, you have to substitute the kinetic friction force. So kinetic friction force is 18. So when you substitute this 18 into the displacement will be 10. Here why we are having a minus sign? Kinetic friction, or the friction will be opposite to that of the movement of the object. So you have this minus sign. So minus 18 into 10, it is 180. So the total work done, if you find, one work done is 200, the other work done is minus 180. So 200 minus 180, it is 20 Joule. So the total work done is 20 Joule. Sixth problem. An object of mass 1 kg is falling from a height 10 meter, which you can see in the animation below. Now we have to calculate the total energy of the object when it is at a height h is equal to 10 meter. Next you have to find the potential energy when it is at a height 4 meter. Then the kinetic energy of the object when it is at a height 4 meter. And what will be the speed of the object when it hits the ground? The g value is given as 10 meter per second square. So first let us find the total energy. When the object is at a height, it will be having the potential energy only. So potential energy is given by mgh, mass into g value into h value. Substituting the mass as 1, g as 10 and the height as 10 meter, you will get the total energy as 100 Joule. When an object is at a particular height, it will be having only a potential energy. So here the total energy is 100 Joule. Next we have to find the potential energy at the height h is equal to 4 meter. Here also we are using the same formula for potential energy, U is equal to mgh. Instead for h value we have to substitute as 4. So when you substitute and multiply, you will get the answer as 40 Joule. Next we have to find the kinetic energy when it is at a height 4 meter. But here velocity is not given. If velocity is given only, you can find the kinetic energy. But we know the potential energy at h is equal to 4 meter. that value is 40 joule. And the total energy, we know that it is 100 joule. So the sum of the energy will be always a constant, which will be 100 only. In this case, it will be 100. Sum of the energy means kinetic energy plus potential energy should be 100. So kinetic energy plus potential energy is equal to 100. So kinetic energy can be easily found by total energy minus potential energy. Total energy is 100 minus the potential energy is 40. So the kinetic energy value can be easily found as 60 joule. Next, we have to find at what speed the object hits the ground. So for finding this, we use our second equation of motion, which is v squared is equal to u squared plus 2as. U is the initial velocity. Initially, the object will be at rest. So u value is given as 0. S is the displacement. Here the object is displaced at a certain height. So S, the displacement can be replaced by the height h. So substituting these values in the equation, you have v square is equal to 2gh. So v will be square root of 2gh. So substituting the g value and h value, we get the v value as square root of 120. Now we find v square. So v square will be 120. So kinetic energy first we shall find. So kinetic energy is given by half mv square. So half into m value is 1 kg. V square value now we found it as 120. So multiplying you will get the kinetic energy is 60 joule. Our aim is not to find the kinetic energy, is to find the speed. So kinetic energy, from kinetic energy we have to find the value of speed. When the object hits the ground, it will be having only kinetic energy because at the ground it will not be having any height. So when any object has height only, it will have the potential energy. When the object hits the ground, touches the ground, the height will be 0. So it will not be having potential energy. Purely it will be a kinetic energy. So the total energy, again it will be a constant only. In the first case we had found the total energy as 100 joule. So still the last case it will be 100 joule only. So the total energy is equal to 100 joule. Here the total energy is in the form of kinetic energy. So half mv squared is equal to 100. From this we can find the value of v square by taking that half and m to the equation that side. So half and m, when it goes to that side, it goes as 2 by m. So 2 by m into kinetic energy is equal to v square. So v will be equal to square root of 2 by m into kinetic energy. So 2 divided by m value is 1. Kinetic energy value is 100. So simplifying, we get the value of velocity as 14.12 meter per second. The next problem, 7th one, let two springs A and B, which is given in the animation below, such that Ka is greater than Kb. Ka and Kb are the spring constant of the two springs A and B. On which spring will more work has to be done if they are stretched by the same force? So in the given two springs, same force is acting. We know the formula for force, F is equal to Kx. But here two objects are there. So F is equal to Ka which is equal to Kb because both the springs same force is acting. So instead of Fa, Fb, we have it as F. From this equation, we are finding Xa. So Xa will be F by Ka. The second one, it will be Xb will be F by Kb. This you have it. Next, what we are going to do is we are going to find the work done. So work done is stored as the potential energy in the spring. So the potential energy is given by the formula U is equal to half Kx squared. Here it is UA. So UA for the first one and UB for the second one. So UA is equal to half KaXa squared and UB is equal to half KbXb squared. Now divide UA by UB. So when you divide the LHS, you have UA by UB is equal to, when you divide the RHS, half is common in the numerator and denominator. So it will get cancelled and you will have Ka xa squared divided by Kb xb squared. Now, first we have formed one expression for xa and xb as f by ka and f by kb. That we are going to substitute here. So when you substitute here, you get ka into f by ka the whole square divided by kb into f by kb the whole square. F is common in the numerator and denominator, so you can cancel the f squared. Similarly, ka is in the numerator and you have got 1 by ka squared. So simplifying in the numerator and denominator, the same simplification. When you do, you get the answer as 1 by ka divided by 1 by kb. So when you take it to the numerator, you have ua by ub is equal to kb by ka. Here it is given that ka is greater than kb. The ratios are equal. That only we have found now. ua by ub is equal to kb by ka. Since Ka is greater than Kb, which implies that Ub should also be greater than Ua. That is, work done. More work is done on the object B than the object A. Eighth problem. A body of mass 100 kg is lifted to a height 10 meters from the ground in two different ways. See the first way which is shown in the animation. What is the work done by the gravity in both the cases? First case it is lifted like this. Second case it is shown in the second slide where we lift the object through the ramp. And here the question is, what is the work done by gravity in both the cases? Then we have to find why it is easier to take the object through the ramp. So first we will find how much force is needed for lifting the object in path 1 and what is the work done in path 1. Then we will move on to path 2. So in path 1 we can easily find the force as F1 is equal to, here the force acting on the object is only the gravitational force which is given by mg. So m is 100. So into g value is 10. So here the total force acting on the object is 1000 Newton. Now the distance moved along the path is the height. Through the height only we are moving through the distance. So h is equal to 10 meter. So the work done we can easily find using the formula. Work done is equal to F dot dr. Here it is F into, instead of dr we have the height. Displacement is the height here. So 1000 into 10 you have got 10,000 joule. So the total work done in bringing the object along path 1 is 10,000 joule. Now we will see the second case. See the animation how it is brought in the second case. It is brought through the ramp. So the minimum force F2 what we apply to lift the object is not equal to mg here. This case already we have discussed earlier in the theory part. Here in this case mg is inclined at an angle theta. So we have to resolve mg into mg sin theta and mg cos theta. Only mg sin theta will be acting along the ramp. So mg sin theta will be less than mg only. So now the theta value, if you see the diagram, the theta value is given as 30. So we are finding the mg sin theta, that is the component of gravitational force. So m value is 100, g value is 10. So into sine, theta value is given as 30. So sine 30 is 1 by 2 which is 0.5. So here the total force required is 500 Newton. Previous case we had found that the total force required is 1000 Newton. But here it is only 500 Newton. So only it is easier to lift the object through the ramp. So next we have to find the total work done. So total work done, the formula is F into displacement. F we know that we have found it as 500. Displacement you have to find the slanting length L. So what we are doing is we are taking this triangle. You can see this right angle triangle if you follow my pointer. So in this triangle, this angle is 30, this angle is 90. So this is your hypotenuse. So sine 30 will be h, that is this h height divided by the hypotenuse. Hypotenuse is here, it is denoted by L, that is the slant length. So sine 30 will be equal to h by L. We need to find the value of L. So L will be equal to, you have to reverse the formula, which is h by sine 30. H is 10. Sine 30 we know that it is 1 by 2, which is written as 0.5. So 10 divided by 0.5, which is 20 meter. So 20 meter is the slant height. That is the length of the ramp is 20 meter. So the work done is given by F dot dr. F is 500 Newton. The distance is the length of the ramp, which is 20 meter. So when you multiply, you get the work done as 10,000 joule. Ninth problem. An object of mass m is projected from the ground with initial speed v0. Find the speed at height h. So initially it is having a speed of v0. Since it is having a speed v0, it will be having a potential energy. Since it is moving with the velocity, it will be having a kinetic energy. So since its velocity is v0, the kinetic energy is given by half m v0 square. This is the initial energy. Since it is having a kinetic energy, the potential energy will be 0. So the total energy is a sum of potential and kinetic energy, which is 0 plus half m v0 square, which is equal to half m v0 square. So after it reaches a height h, it will be having potential energy as well as kinetic energy. Potential energy is mgh, kinetic energy is half mv square, where small v is the velocity after certain height. So here the total energy is half mv square plus mgh. Now we have to find the speed at height h. So for finding this, we are using the law of conservation of energy. That is, initial energy will be equal to final energy. Now initial energy and final energy already we have got in the tabular column. So we have to equate them and then we have to find the value of velocity. So when you equate them, you have half m v0 square is equal to half mv square plus mgh. Multiply the above equation by 2 throughout. So we will have m v0 square is equal to mv square plus 2 gh. So we need to find v. So taking 2gh to the other side, we have v squared is equal to v0 square minus 2gh. Our aim is to find v. So taking square root on both the sides, we have v is equal to square root of v0 square minus 2gh. This is the value of speed at a height h. The 10th problem. An object of mass 2 kg is attached to a spring, is moved through a distance x is equal to 10 meter from its equilibrium position. The spring constant K is given as 1 Newton per meter and assume that the surface is frictionless. When the mass crosses the equilibrium position, what is the speed of the mass is asked? And what is the force that acts on the object when the mass crosses the equilibrium position? And the extreme position x is equal to plus or minus 10 meter. So when you have the extension x is equal to 10 meter, the energy will be totally potential energy since it has got a displacement, that is the height through which it has displayed. It will be having the potential energy only. So first let us find the value of potential energy. U, we know the formula as U is equal to half kx square. So half into k value is given as 1 and x value is given as 10 meter. It is the value of x. So substituting here, multiplying, dividing, you get the value of energy as 50 joule. Now, when the object crosses the equilibrium position, what is the potential energy is asked? The equilibrium position is nothing but the mean position, that is x is equal to 0. That is called as the equilibrium position. X means the displacement. Whenever there is no displacement, that is said to be an equilibrium position. When you apply a force only, it will be displaced through a distance. When no force is applied, it will be in equilibrium position. That is the rest position. The rest position is defined as the equilibrium position, which is x is equal to 0. So here the potential energy will be, as per the formula, it is half kx squared. Since x is 0, the potential energy when the mass crosses the equilibrium position will also be equal to 0. So the entire energy, potential energy is fully 0. So the entire energy when the object is moving or when it is crossing the equilibrium position will be the kinetic energy. So kinetic energy is half mv square. So which it will be equal to 50 joule, because the total energy we have found it as 50 joule. Since potential energy is 0, kinetic energy only should be there. We don't know the value of kinetic energy, but the sum of potential and kinetic energy should be equal to the total energy. Here potential energy is 0, total energy is given as 50 joule. So the kinetic energy should be equal to 50 joule. So now using this formula, we can easily find the value of speed. Mass and m divided by 2. Take it to the equation that side. It goes as 2 divided by m. That is 50 into 2 by m. So simplifying, you will be getting the answer as square root of 50, which is nothing but 7.07 meter per second. This is the speed. Next, what is the force that acts on the object when the mass crosses the equilibrium position and extreme position, they have asked. Here the force is nothing but the restoring force. You apply a compression or you expand the spring, you remove the force, what happens? The restoring force acts on the object and it brings the spring to its initial position. So that is the restoring force. Here it is restoring spring force is F is equal to minus kx. It will be having the formula as F is equal to minus kx. Since x is equal to 0 at the equilibrium position, at equilibrium position it doesn't experience any force. Next, when the object is at x is equal to 10 meter, they are asking us to find the restoring force. So substituting x is equal to 10 in F is equal to minus kx, you have F is equal to minus 10 Newton. The negative sign shows that the force will be towards the equilibrium, that is towards the negative x-axis. Next we have to find for compression. So compression means the displacement will be x is equal to minus 10. So again substituting this in the restoring force equation, F is equal to minus kx. Here when you substitute, you will get the answer as plus 10 Newton. So since it is plus, this force points towards the positive x-axis. So these are the values of restoring force. Eleventh problem. Water in a bucket tied with the rope is whirled around in a vertical circle of radius 0.5 meter. Calculate the minimum velocity at the lowest point so that water does not spill from in it in the course of motion. G value is given as 10 meter per second square. So radius is given as 0.5 meter. We know the value of the expression for the highest point. That is the velocity at the highest point. In theory part we would have learned that V2 is equal to square root of GR. So square root of G value is 10 into R value is 0.5. So 0.5 into 10 it is 5. So root 5 is the value of speed at the highest point. Similarly, the speed at the lowest point is given by V1 is equal to square root of 5 GR. This is the formula which we had learnt in our theory part. So which is equal to root 5 into root GR. Root 5 into root GR, already we have found it as root 5. So root 5 into root 5 is nothing but 5 meter per second. The 12th problem. Calculate the energy consumed in electrical units when a 75-watt fan is used for 8 hours daily for 1 month. So this 1 month consists of 30 days they have given. So power consumed is 75 watt. The time of usage is 8 hours per day. One day it is 8 hours. So for 30 days it will be 30 into 8 hours. So 30 into 8 it will be 240 hours. So totally the fan was used for 240 hours. So the electrical energy consumed. Electrical energy we know the formula as power into time. Power here it is 75 watt and time it is 240 hour. So when you multiply you will get 18,000 watt hour. 1000 we know 1000 is represented by kilo. So the answer is 18 kilowatt hour which is represented by 18 kWh. We know that 1 electrical unit is 1 kilowatt hour electrical energy. Hence 1 kilowatt hour is represented as 1 unit. So the answer is 80 unit. 13th problem. A vehicle of mass 1250 kg is driven with the acceleration of 0.2 meter per second square along a straight level road against an external resistive force of 500 Newton. Calculate the power delivered by the vehicle's engine if the velocity of the vehicle is 30 meter per second. When the vehicle is moving, we need to find the power delivered by the vehicle's engine. We know the relation between power and velocity as P is equal to F into velocity. But here two forces are acting. One is the force with which it is accelerated. Another one is the force which is the resistive force. So we need to, instead of F, we have to find the total force which is a sum of resistive force and the force with which it is driven with an acceleration 0.2 meter per second square. So we have to add that force and you have to substitute here. So P is equal to F total into V. F total is the resistive force plus the force due to which the car is accelerated. That we have to substitute F is equal to ma. Here resistive force, we have to find the value of resistive force. Here the resistive force is given in the question as 500 Newton. So 500 Newton plus m into a. M is 1250 into acceleration is 0.2. So when you have to add this and then you have to multiply with the velocity which is 30. So you get the power as 22.5 kilowatt. Problem. A lighter particle moving with the speed of 10 meter per second collides with an object of double its mass moving in the same direction with half of its speed. Assume that the collision is a one-dimensional elastic collision. What will be the speed of both the particles after collision? So two objects are there. First object mass is m1 is taken as m. Second object mass is twice that of m. So we are having m2 as 2m. Initial velocity of first object is 10 meter per second. Second object's velocity is, in the question it is given that half its speed. So here it is 10 means here it should be 5 meter per second. We have to find the final velocity. Final velocity already we have seen in the derivation of elastic collision. The final velocity is given by the formula m2 minus m1 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Here we are going to substitute the m1, m2 all values in this equation and then we are going to find the final velocity. Here in the animation you can see how the object is colliding with the other object.
Yeah, substituting the values we get V
is equal to m minus 2m divided by m plus 2m into 10 plus 2 into 2m divided by m plus 2m into 5. So simplifying, you get V1 is equal to 1 by 3 10 plus 4 by 3 5, which is equal to minus 10 plus 20 divided by 3, which is 10 divided by 3. The answer of V1 is 3.33 meter per second. Now we have found the value of V1. Next we have to find the value of V2. V2 is given by 2m1 plus m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. Substituting the value of m1, m2, u1, u2, we get the answer as 2m divided by m plus 2m into 10 plus 2m minus m divided by m plus 2m into 5. So m you can cancel in the numerator and denominator. So you have 2 by 3 into 10 plus 1 by 3 into 5. Simplifying, you get 20 plus 5 divided by 3, which is equal to 25 by 3. Hence V2 is equal to 8.33 meter per second. Fifteenth problem. A bullet of mass 50 gram is fired from below into a suspended object of mass 450 gram. The object rises through a height of 1.8 meter with the bullet remaining inside the object. Find the speed of the bullet. And you have to assume G value as 10 meter per second square. The problem is explained in the animation at the bottom. This type of collision is inelastic collision. So M1 value is given as 50 gram, which has to be converted into SI unit, which is 0.05 kilogram. M2 is given as 450 gram, which is nothing but 0.45 kilogram. The speed of the bullet is assumed to be U1. The object speed is assumed to be 0 because it is embedded. It is just the red color object is just hanging. It is at rest. So U2 is equal to 0. So the common velocity after you fire the gun, both are moving with the same velocity. That we assume it as V. So in the inelastic collision definition, which we had discussed in the theory, we would have derived this equation for the common velocity. So we are using this equation. So V is equal to m1 u1 plus m2 u2 divided by m1 plus m2. Substituting m1 value, m2 value, u1 value and u2 value. u2 value we know that it is 0. Substituting all these value in this equation and simplifying, we get V is equal to 0.05 divided by 0.50 u1. You can have this equation for further simplification. So have this equation. Next we will be finding the combined velocity will be the initial velocity for the upward motion. So from the second equation of motion, this equation already we have discussed in the about two problems. V squared is equal to u squared plus 2gs. There u is assumed to be 0. So substituting u as 0 in the equation and further simplifying, we will get this equation. V is equal to root of 2gh. Substituting the g value and h value. H value is given as 1.8 meter. It is rising up. So h is 1.8. So substituting these values and simplifying, we get V is equal to square root of 36. That is 6 meter per second. Already in the first derivation, we have got the answer as combined velocity V is equal to 0.05 divided by 0.5 u1. Now the combined velocity V, we have got it as 6. So substituting that value in this equation, we get V is equal to, that is 6 is equal to 0.05 divided by 0.5 u1. We need to find the value of u1. So u1 is equal to 6 into 0.5 divided by 0.05. So further simplifying, you will get the value of u1 as 60 meter per second. show that the ratio of velocities of equal masses in an inelastic collision when one of the masses is stationary is V1 by V2 is equal to 1 minus E divided by 1 plus E. So we know that E is called as the coefficient of restitution. From the formula of E, we have E is equal to velocity of separation divided by velocity of approach, which is equal to V2 minus V1 divided by U1 minus U2. This is the formula for coefficient of restitution. Here the first object is at rest. So U2 is substituted as 0. So V2 minus V1 divided by U1. This is the value of E. Now E is equal to V2 minus V1 by U1. U1 is in the denominator. Take U1 along with E. So we have V2 minus V1 is equal to E into U1. We know the law of conservation of linear momentum. The momentum before collision is equal to momentum after collision. So substituting that formula, we have m into u1 is equal to m into v1 plus m into v2. So we can cancel m throughout. So we will have u1 is equal to v1 plus v2. Now substitute this value of u1 in the first coefficient of restitution equation. We get v2 minus v1 is equal to E into, instead of u1 you have to substitute v2 plus v1. Now we have to take E inside the bracket and multiply. We get v2 minus v1 is equal to E v1 plus E v2. Now taking V2 on one side, V1 on one side, we have V2 minus EV2 is equal to EV1 plus V1. Now we can take V2 common in LHS and V1 common in RHS. So we will have V2 into 1 minus E is equal to V1 into E plus 1. So E plus 1 can be written as 1 plus E, just a small rearrangement. Now we can find the value of V2 by V1. So V2 by V1 is equal to 1 plus E divided by 1 minus E. We have to prove V1 by V2. So again taking reciprocal, we have V1 by V2 is equal to 1 minus E divided by 1 plus E. Hence we have proved. Question. Calculate the work done by a force of 30 Newton in lifting a load of 2 kg from a height of 10 meter. Here you would have seen in the animation how the object is lifted. So we need to find the work done. Work done is given by F dot dr, where dr is the height through which the object is moved. F we have to find. F is already given in the question as 30 Newton. So work done is equal to F into H. F is 30, height is H. So 30 into 10, which is 300 joule. This is the work done. 18th question. A ball with a velocity of 5 meter per second impinges at an angle of 60 degree with the vertical. You can see in the diagram, you have got the pink color surface is the horizontal to which a ball is thrown at an angle 60 degree. After the ball is thrown, how a light ray gets reflected. Likewise, this ball is bouncing back through some angle. So we need to find the velocity and direction after the impact. So the velocity of ball is given as 5 meters per second. The angle of inclination with the vertical is 60 degree. The coefficient of restitution is given as 0.5. Here the given problem is analyzed with the inelastic collision. How? No? So initially a ball is coming and it is colliding with the surface. So object 1 is the ball and object 2 is this pink color surface. So this surface will be acted as a another one object. So this object, no, this surface will be at rest before collision and after collision only. So the value of velocity before collision of this object, second object, will be 0. Now using this we are going to find the coefficient of restitution. So E is equal to, we know the formula as V2 minus V1 divided by U1 minus U2. Here we know that V2 and U2 values are 0. Since the surface cannot move, their velocities will be 0. So substituting in this equation those values we have, E is equal to V1 by U1. So V1 will be, take U1 to the other side, you have V1 is equal to E into U1. So we know the E value as 0.5. So V1 is equal to 0.5 into U1, or else you can write it as U1 is equal to V1 divided by 0.5. 0.5 value is 1 by 2. So V1 is equal to U1 by 2. So this we will be using in the further calculation. So have this equation. Next, this U1 velocity, if you see the diagram, it is inclined at an angle 60 degree. So you can resolve this velocity into two components, which is U1 cos 60 and U1 sin 60. So these are the two components of the velocity. So we are going to find these components value. So U1 sin 60 is, U1 is equal to 5. Sin 60 we know that root 3 by 2. So the value is 4.33. Similarly U1 cos 60 is 5 into cos 60, the value is 1 by 2, which is equal to 2.5. Here what did we find using the coefficient of restitution? V1 is equal to U1 by 2. U1 is 2.5. So 2.5 divided by 2 will be 1.25. So if you see the diagram, this value, this vertical value is 1.25 and the horizontal one is 4.33. This 4.33 value of velocity will be constant. The horizontal value will be constant and the vertical value only will be changing. So here what vertical value we got it as 2.5. Using the coefficient of restitution, we got the value as V1 is equal to U1 by 2. So here U1 is 2.5. So 2.5 divided by 2, it will be 1.25. So if you see the diagram, the vertical component value is, in the first case before collision, it is 2.5. So after collision the value is changing as V1 is equal to U1 by 2. Hence it is 1.25. That is 2.5 divided by 2. So it is 1.25. This is the change in vertical component. But the horizontal component will be the same. See the horizontal component, initially it is 4.33. In the next side, after collision also it is 4.33 only. So after collision also the two components of the velocity, that is the horizontal component, will be the same only. The vertical component we had found it as 1.25. Next we will find the angle in which the velocity is moving. So we need to find the tan theta. So you can take this triangle, this small triangle. If you follow my pointer, you can easily identify theta. So tan theta is equal to opposite by adjacent. Opposite is 4.33. Adjacent is, this is the adjacent side. So here it is, the parallel side value is 1.25. So here also it will be 1.25. So tan theta is equal to 4.33 divided by 1.25, which is nothing but 3.464. So theta will be equal to tan inverse of 3.464, which is nothing but 73.9 degrees. Now we have found with this angle only it is inclined. The final velocity is inclined at this angle. So this angle gives you the direction. So direction we have found. Next we have to find the velocity. So the final velocity is given by V1 square. So this is it. This is the V1 square. You can easily find this is the resultant velocity one value is 4.33. This is 4.33. Follow my pointer, you will understand. This vector is 4.33. This vector, from this you will have, this is 1.22. So the resultant of these two you can easily found using the formula. V1 squared is equal to square root of 4.33 the whole square plus 1.25 the whole square, which is 18.7489 plus 1.5625. So V1 square is equal to 20.3114. So V1 will be square root of 20.3114, which is nothing but 4.5 meter per second. Nineteenth problem. A bob of mass m is attached to one end of a rod of negligible mass and height, the other end of which is pivoted freely at a fixed center as shown in the figure. What initial speed must be given to the object to reach the top of the circle? We have to use the law of conservation of energy. Is the speed lesser or greater than the speed obtained in the session 4.2.9? Already in this lesson, while discussing this lesson, we would have discussed what is the total energy, what is the maximum vertical speed, what is the minimum speed, all the things we would have derived in the theory part. The same thing we have to find here and then we have to compare them. So when the object is at point 1, the lowest point, and even in the point 2, the total energy should be the constant. So the potential energy at point 1 is 0 because at point 1 it is in the lowest point. It will not have any height. If it has got height only, it will be having the potential energy which is mgh. So h is equal to 0. Potential energy is also 0 at first point. So using the law of conservation of energy, the potential energy is 0. So the kinetic energy will be half m v1 square. So this is the energy at point 1. Now at point 2, it will have the kinetic energy as well as potential energy because it is at a height. So what is that height? The potential energy is given by mgh. So m into g, h is nothing but, just follow my pointer, you can understand the h. H is nothing but 2 times the radius. So this is the total height. So h is replaced by 2r. So the energy is 2 mgr plus the velocity. The velocity, using velocity we can find the height and kinetic energy which is half mv2 square. So half v1 squared is equal to 2gr plus half v2 square. That is, we have divided the above equation totally by m. So when you divide it by m, the m in the numerator and denominator will get cancelled and hence we get this equation. Again to this equation we are multiplying by 2 throughout. So we will be having v1 square is equal to gr plus v2 square. Hence v1 square minus v2 square. v2 you take it to that side. We have v1 square minus v2 square is equal to 4gr. So to find the velocity v1, we have to substitute v2 is equal to 0. The same we would have done in the theory part also. So when v2 is equal to 0, we will have v1 squared is equal to 4gr. Hence, v1 will be equal to square root of 4gr, which is nothing but 2 into root of gr. Here, the speed of the bob which is obtained is less than that of the speed what we have seen in the theory. Here, why it is no? There in the theory part, we would have used the string. But here, instead of string, we are using a massless rod. So the speed is slightly less than that of the string. The 20th problem. Two different unknown masses A and B collide. A is initially at rest and when B has a speed of V, after collision, B has a speed of V by 2 and moves at right angles to its original direction of motion. Find the direction in which A moves after collision. So from the diagram you can understand that two objects are there, A and B. They are colliding with each other. A is at rest but B is moving with the speed of V. So after collision B is moving with the speed of V by 2. And you have to find the direction in which A is moving. That is the theta we have to find. So here we are using the law of conservation of momentum. Law of conservation of momentum states that momentum before collision will be equal to momentum after collision. So here if you see momentum before collision and after collision, if you want to find, we have to know the velocity of the object is, if you see the second diagram, it is the velocity is inclined at an angle theta. That is, the object A velocity is, after collision it is v1 and it is inclined at an angle theta. So we can equate them as v1 cos theta and v1 sin theta. We can have these component of velocity. So these component of velocity when multiplied by m, it will be having the momentum as m1 v1 cos theta and the vertical momentum as m1 v1 sin theta. Here we are comparing the momentum along x-axis and momentum along y-axis. See the momentum along x-axis, it is m1 v1 cos theta. So m1 v1 cos theta, in this side it is equal to m2 v. Similarly, the component along y-axis is, see my pointer, you will understand. m1 v1 sin theta is equal to, here the value is m2 into, the velocity is halved. So m2 into v by 2. So these are the two equations. Here we need to find the angle of theta. So what we are going to do is dividing equation 2 by 1. So when you divide 2 by 1, m1 v1 which is in the numerator and denominator in the LHS get cancelled. Sin divided by cos is nothing but tan theta, and in the RHS m2 will be cancelled, v will be cancelled. You will be having tan theta is equal to 1 by 2. So theta will be tan inverse of 1 by 2, which is nothing but tan inverse of 0.5. The value is theta is equal to 26 degrees 33 minutes. First problem, a bullet of mass 20 grams strikes a pendulum of mass 5 kg. The center of mass of the pendulum rises a vertical distance of 10 cm. If the bullet gets embedded into the pendulum, calculates its initial speed. In the animation, you can see how the bullet is embedded in the pendulum. Imagine the speed of the bullet as v. The common velocity after they get impinged, that is here this type of collision is inelastic collision. So after collision both of them move with the common velocity which is given by capital V. So according to the law of conservation of linear momentum, this we would have already derived in the theory part. V is given by m1v divided by m1 plus m2. So substituting m1, m2 value and simplifying, we have v is equal to 0.004 v. Now we need to find the value of velocity. So we are using the third equation of motion. V squared is equal to u square plus 2gs. Here initially the bullet is at rest. So u is equal to 0. So v square is equal to 2as. A is replaced by the acceleration due to gravity. So v squared is equal to 2gs. V, we know that capital V is the combined velocity. In the previous paragraph only we have derived an equation for V as 0.00v. That is capital V. The combined velocity is 0.00v we have found. So substituting that for V, we have 0.004v the whole squared is equal to 2 into small g value is 9.8 into s, the displacement value is 10 meter into 10 power minus 2. So v squared is equal to taking 0.004 the whole square to the denominator and simplifying, we get the value of v as 350 meter per second.